In this section, we're going to talk about formal charge. Now, I mentioned it in the previous video, and it's important to be able to calculate formal charge. And again, remember a nice little review of general chemistry. Formal charge is simply the charge that we give on a particular atom depending on the number of electrons around it. And interestingly enough, it seems like every textbook has its own rules for calculating formal charge of an atom in a molecule. Now, this can be fairly confusing. Your general chemistry textbook might tell you one thing, um, Maitland-Jones might tell you another thing. Well, I'm going to give you my definition of calculating formal charge, and it seems like it's the easiest one that I know how to teach students, right? And the way that you do this to calculate formal charge is you simply take the number of valence electrons of that particular atom, you subtract all of the non-bonding electrons from that, and then you simply subtract the bonds. Now, oftentimes you'll hear or read in textbooks, you subtract half the number of electrons in the bonds and so on and so forth. Well, if you think about a bond has two electrons. Half of the two electrons is one. So if you're simply subtracting a bond, then you will get the number of correct electrons from that. And for me, it's a little quicker way of calculating formal charge of all of the atoms, especially if you're looking at a structure that has several atoms and you have to, quickly think about the formal charge of all of them, right? So again, let's look at an example of this. I'm just going to go over a couple of examples. Here we have ammonium. Now I've given you the charge of ammonium, and if I didn't give you the charge, you would still be able to figure out the charge of that particular structure when you actually draw the Lewis structure of it, right? So ammonium has nitrogen with 4 hydrogens around it, and if you go back to the previous video, you can use the rules that we applied to actually determine the Lewis structure of ammonium. Okay, now, in this section, though, we want to think about formal charge. So the formal charge is the charge on each particular atom. So the hydrogen atom and the nitrogen atom. Obviously, we know that ammonium has a plus charge. The question is, where does that plus charge reside? Does it reside on a particular atom, or is it distributed throughout a number of atoms? Well, that is why we calculate formal charge. And hydrogen, the formal charge of hydrogen is relatively easy. We have one valence electron of hydrogen, and each of those hydrogens only has one bond, so we're going to take one electron minus one bond, and that gives us a formal charge of 0. So all of the hydrogens in ammonium have a 0 formal charge. The nitrogen, on the other hand, again has 5 valence electrons. We saw a previous example where nitrogen has 5 valence electrons. And it doesn't have any non-bonding electrons around it, so there's no pair of electrons on the nitrogen. But it does have 4 bonds. So we're going to take 5 minus 4, and that gives us a plus 1 formal charge. In order to show that plus 1, we're going to draw it next to the nitrogen atom. Now, when we have a formal charge of plus 1, we typically just write plus, and so we're simply going to draw a plus, and I tend to circle it. Some people don't, but I like to circle that plus to kind of highlight that formal charge on the nitrogen, right? And so this is the Lewis structure in its completion, including formal charges. Another example is this, OH, and the oxygen has 6 pairs of electrons around it. Now, I'm not giving any charge around it, so I don't, I'm not telling you if there's any charge around it. How would I find possible formal charges of OH? Well, again, I have to understand the Lewis structure. So that oxygen is bound to hydrogen, so we can draw a bond, right? A bond line between oxygen and hydrogen. And of course, I'm going to draw all of the 6 electrons around that oxygen. Now, hydrogen, when calculating formal charge, we know hydrogen, just like above, has 1 valence electron, 1 bond, therefore it has no formal charge. So the formal charge is 0, I should say. Oxygen has 6 valence electrons. How many electrons do we have around it? Well, notice we have 6 non-bonding electrons, 3 pairs of electrons. That's 6 non-bonding electrons. And then oxygen has 1 bond. So we subtract 1 bond. So 6 electrons, valence electrons, minus 6 non-bonding electrons, excuse me, minus the 1 bond gives a -1 formal charge. So that -1 formal charge goes to the oxygen, right? It doesn't go to the hydrogen because hydrogen has a formal charge of 0. It goes to the oxygen. Again, when we have a -1 formal charge, we simply write a minus sign next to the atom that has that formal charge. And so this is hydroxide, OH minus. And in general, if you're just showing the structure of OH minus, you would have a negative sign, which denotes that there is a negative charge there. So that's how you calculate a formal charge, a quick little review of calculating formal charges. I hope this helps out in your review and understanding of formal charges. So again, get practicing.